Okay, everyone, let's take a look at 5.1, working with radicals. So this is really going to be a review and a preview of what we're going to be dealing with for the next unit. So when we talk about radicals, radicals can be expressed as a mixed or an entire radical. When we're talking about a mixed radical, it just means that it's got a coefficient that is not 1 or -1. If I have an entire radical, it has a coefficient that is 1 or -1. Like radicals are kind of like terms. Like radicals mean that it's two radicals that have the same index and same radicands, but they could have different coefficients. Just like if I had like variables or like terms, if I had 3x and 5x, they both have the variable x, which means that I can combine them. Radicals can be added or subtracted only when they are like radicals. If I'm going over the multiplication rules, then as long as they have the same index and it is a natural number, then if I have a times b and the square root, then it's going to be the same as the square root of a times the square root of b on the outside. So I can just combine the radicands. A radical in simplest form is a radical term where the radicand does not contain any fraction or any factor which can be removed, which means that it should not have a fraction in the radicand, and it shouldn't have a perfect square if it's square root, or a perfect cube if it's a cube root that you can divide out of there to simplify it into a mixed radical further. Also, the denominator cannot contain a radical. So, these are examples of radicals not in simplest form. If I have the square root of 18, well, this one isn't going to work because I could divide it by the square root of 9. If I have 2 over root 3, well, I have a radical in the denominator. And if I have -2 and the square root of 7 over 9, well, there's a fraction inside the radicand. When I talk about restrictions on a variable, then you need to identify the values of the variable that makes a number possible. So first off, I already know I can't divide by 0. It doesn't matter if it's a square root of 0 or just 0, I can't divide by 0. It doesn't work. I also can't take the square root, 4th root, 6th root, or anything like that of a negative number, because if it's multiplied by itself a even number of times, it's always going to be positive, so it's just not possible. If the index is odd, the radicand can be any number, because I could say -2 times -2 would be +4, but times -2 again would be -8. So this rule only applies if it is an even number. It has the negative restriction. If it is an odd numbered index, it doesn't. Odd numbered indexes can work for anything. Alright, so if we put this into practice, the first thing, we're going to state the restriction on the variable for the radicals to be real. Well, if I'm looking at a square root here, then I know that what's inside the radical has to be positive or equal to 0, otherwise it's not going to work. Which means that I'm going to start by saying what's inside the radical, put that in brackets, has to be greater than or equal to 0, because it can't be negative. Then we use our inequalities abilities from our last unit to just say, well, x would have to be greater than or equal to 2, which means as long as x is 2 or bigger, this is going to work. There's our restriction. If I'm stating in the second case that x times y has to be greater than or equal to 0, then that's basically what I'm stating. I'm stating that if x is positive, then y has to be positive to multiply to make a number bigger than 0. Or if x is negative, y would also have to be negative to multiply to make a number bigger than 0. When I get to the third example, as soon as I see that it is a cube root, I don't have that negative restriction because what's inside could be negative, which means that I'm just going to state x can be any real number. And for D, the only thing that makes this one a little bit trickier is 1, I have a square root here, so I can't have a negative in the bottom. So normally I would say that 3 minus x has to be greater than or equal to 0. But because the radical is also in the denominator, I know it can't equal 0 because I can't divide by 0. So I'm just going to have to say that 3 minus x has to be greater than 0. If that's true, then negative x has to be greater than negative 3, or x actually has to, when I divide by the negative, be less than positive 3. So make sure you're flipping those signs, just like we did in that last unit. Alright, if I'm converting mixed radicals to entire radicals, then all I'm doing is I'm going to rewrite the coefficient as though it was a radical with the same index as whatever it's being multiplied by. In this case, if I have 3 times the square root of 5, I'm going to rewrite what 3 would be the square root of. Well, we already know that 3 is the square root of 9, or 3 would be equal to the square root of 3 times 3. Which means that here, I can say that if I'm rewriting it, it's the same as the square root of 3 times 3 times the square root of 5, and I can multiply all of that inside my radical. Which is going to give me the square root of 45. If that's true, then if I look at the second one where I have an index of 3, then 2 would be the same as the square root of 2 times 2 times 2. So I can just say that, well, this is going to be equivalent to the cube root of 2 times 2 times 2 times 5, which is going to give me the cube root of 40. If I'm doing it with variables, it works the same way. If I have a times b times the square root of c, then that's just going to be the square root of a times b times a times b, and then the c was already on the inside. I have a squared, I have b squared, and I have c. And for the last example, I'm going to say this is equivalent to the cube root of 5 times 5 times 5, b times b times b, and then I already had a 3 and a b squared that was on the inside. I'm going to combine the like terms. 5 times 5 times 5 is going to be 125 times 3 is going to give me 375. And I have b times b times b is b cubed times b squared is going to give me b to the 5. Alright, we should already remember from last year that fractional exponents, if I have to the power of 1/2, it's the same as the denominator of the exponent becoming the index of the radical. The same thing holds true here. 1 over 3 is going to give me the cube root, or m over n is going to give me the nth root, and then the numerator just stays as the exponent. We also know that if I multiply two bases, or two powers with the same base, I'm going to add the exponents. If I divide them, I'm going to subtract. If I do a power law, so a power and then a bracket to another power, I'm going to multiply it. And anytime that I have a power of 0, it's always going to be 1, so long as the base is not also 0.